Hello, we are from Group 5. So today we're going to present our integrated design project which entitled Production of Acetaldehyde from Ethylene by Air Oxidation. Acetaldehyde is also known as ethanol and has a formula of CH3CHO. So it is a clear liquid and has a strong pungent odor. So the boiling point for this chemical is 20.2 degrees Celsius and the melting point is negative 123 degrees Celsius. So the predominant use of acetaldehyde is it is used as intermediate in the synthesis of other chemicals. Other than that, acetaldehyde is also used in the production of perfumes, in the production of basic dyes, and it is also used as a flavoring agent, for example, for yogurt production. Generally, there are four ways in order to produce acetaldehyde. The first one is the oxidation of ethylene. The second one is hydration of acetylene. The third one is hydrogenation of acetic acid. And lastly, the oxidation of ethanol. But for this project, we're going to focus on the oxidation of ethylene. In order to produce acetaldehyde is known as Wacker-Chemie method, and this method was developed in 1950s, which basically has two types, which is one stage type and then two stage type. In this case study, we use one stage type in order to produce acetaldehyde because it is more economical. So what happened here is ethylene and oxygen is being fed into the reactor containing palladium chloride as catalyst with the operating pressure of 400 kPa and temperature of 130 degrees Celsius. So this leads to the production of acetaldehyde, water vapor mix, and unconverted gas. And then it goes to the scrubber where exhaust gas will be removed. And then it goes to the distillation column, which is also known as extractive distillation, where like end products is extracted and removed. Which they have a lower boiling point than acetaldehyde, for example, chloromethane, carbon dioxide, and chloroethane. And the last distillation column is where the acetaldehyde is being purified by fractional distillation, where the boiling point is set higher than the boiling point of the acetaldehyde. And then so we retrieve the acetaldehyde at the top product.
Hi, my name is Lim Ying and I will talk about heat exchanger network for this process. In this project, we need to produce acetaldehyde from ethylene by air oxidation. So we have designed two process flow diagram. The first process diagram, we design it without the utilizing of heat exchanger as shown here. For the second process flow diagram, we design it with the addition of heat exchanger after the heat integration is done. So after heat integration, we have added two heat exchanger into the process because we want to minimize the utility of heater and cooler. Next, we will proceed to the calculation part. First, the required data from each stream has been extracted from the symmetry report, and then we will convert all the data into the units that are suitable for our calculation later. After the unit conversions, the average Cp for each stream can then be calculated. After that, we will use this average heat capacity to calculate the specific heat capacity. Next, we proceed to the heat exchanger network. So we will first assume that the T minimum is 10 degrees Celsius, and the interval temperature for both hot stream and cold stream can be calculated using the formula below. This table shows the calculated value of the interval temperature for each stream. After getting the interval temperature and heat capacity for each stream, the problem table method can be used to solve the heat exchanger network. The problem table is shown here, where we can know the minimum hot utility and minimum cold utility. And then we can also find the pinch temperature for above pinch and below pinch using this formula. And after obtaining the pinch temperature, the heat exchanger network can then be designed and drawn. So from here, we know that the minimum hot utility requirement is 7.38 kilowatt, while the minimum cold utility requirement is 110.517 kilowatt.
Hi, I am Anwar and I will be presenting about the material science part, in which the material selection for separation unit, which is the distillation column, it is used to separate the different components in a fluid by using their difference in the boiling point. So there are two parts, which is the bottom column and top column, in which for the bottom column it contains a large volume of liquid as it travels downward, and the reboiler is used to reheat the liquid and return it into the column known as boil up. As for the top column, the vapor travel upward through the holes of the plate and simultaneously in contact with the liquid that go through the bottom column. So the condenser is used to return the vapor to the column in liquid state and known as a reflux. So these are the potential materials suitable for the distillation column. The first one is the stainless steel 316, in which it has the advantages of high corrosion and chemical resistance and longer durability, while the disadvantages is quite expensive and can corrode in the marine environment. As for stainless steel 304, it has the advantages similar to the stainless steel 316. However, it tends to corrode due to chloride solution only or from saline environment. And for the third one is the carbon steel medium. It has the advantages of durability, shock, and fire resistant, while the disadvantages is that it has a low ductility, susceptible to rust and corrosion. So after the comparison between the three materials, stainless steel 316 is chosen as the most suitable material for the designation of the distillation column. So these are the mechanical, thermal and electrical property, in which carbon steel show the highest value for the yield strength and tensile strength, in which indicate the maximum stress that can be developed in the material without causing plastic deformation, and maximum amount of tensile stress that it can be subjected before failure. While for the thermal expansion, carbon steel show the lowest value among the three materials, in which it is a tendency of matter to change its shape, area, volume and density in response to a change in temperature. While lastly for the electric resistivity, stainless steel 316 show the highest value among the three materials. So, mechanical property and thermal property, the best suit material for those property is the carbon steel, while for the electrical property, the best suit for it is the stainless steel 316. However, due to the carbon steel is susceptible to rust and corrosion, stainless steel 316 is deemed to be the best materials for the property.
Hi and a very good day. My name is Vigneshwaran Arjunan. I will be talking about the corrosion and degradation of the selected material for the separation unit. So what is corrosion? Corrosion is the natural phenomenon and the deterioration of the material as a result of its interaction with the surroundings. So for our process, it involves the production of acetaldehyde from ethylene by air oxidation using palladium 2 chloride and copper 2 chloride as the catalyst. So the use of catalyst and the content of hydrochloric acid in the process exhibits extreme corrosion properties to the metallic material of the apparatus. So because of this, the production is actually prompting the use of costly construction material. Therefore, we have chosen 316 stainless steel as the material for our separation unit. We can actually calculate the speed at which the corrosion spread, the amount of corrosion loss per year in thickness, and also the speed at which any metal in a specific environment deteriorates due to the chemical reaction by using the corrosion penetration rate formula, which is CPR is equals to Kw over rho AT. So there are several parameters that were assumed. First are the time of exposure is 1 hour. The area of distillation column is equals to the area of cylindrical vessel. The CPR values of each materials are taken from literature reviews, and we are actually calculating the weight loss. And from this we can see that the stainless steel 304 and stainless steel 316 have the same weight loss, but in the reality stainless steel 316 is actually a better material because there are a certain percentage of molybdenum chemicals is added to the stainless steel, which makes it more corrosion resistant.
My name is Nerissa and I will be explaining about the recommendation to improve safety aspect for the selected separation unit. So we have chosen two methods. We have proposed two methods that are pressure relief valve and hydraulic actuator. A pressure relief valve are basically a basic spring-loaded pressure relief valve. It is designed to fulfill the requirement for a simple, dependable, system-actuated device to guard against overpressure. The advantages of using pressure relief valves are it is easy to maintain, the cleanliness and efficiency in flushing and testing procedures. It can eliminate surges and extend the life of pipes. It can also effectively handle higher pressure application. As for hydraulic actuator, the principles of hydraulic actuator are like pneumatic actuator. Each uses some motive forces to overcome spring forces to move the valve. Also, hydraulic actuators can be designed to fail open or fail close to provide a fail-safe feature. The advantages of using hydraulic actuators are the hydraulic actuator can hold forces and torque constant without the pump supplying more fluid or pressure. Due to the incompressibility of fluids, it is also precise and has minimal periodic maintenance required. To conclude, this project focuses on simulating the production of acetaldehyde from ethylene by air oxidation using ICON software. So basically, we carry out the mass energy balance using ICON software of the process units as well as designing the heating, cooling utilities requirement. The method proposed are 2 hot streams and 2 cold streams involving the usage of cooler and heater. For material science, the main factors are mechanical, electrical, thermal properties of the material, and corrosion and degradation of materials of the selected separation unit. We have chosen stainless steel 316 because it gives a better overall corrosion resistant properties and has higher resistance in pitting and crevice corrosion in chloride environment. As for the safety aspect, the spring-loaded pressure relief valve and hydraulic actuator are chosen for the recommended method. Thank you.